All right, we're going to talk about HL level, Chapter 3, Section O. Today we're going to talk about parallelism and unit vectors. Okay, so if two vectors are parallel, and the only difference is the length of the vector, then we can say that the magnitude of these can be multiplied by some scalar, and then we would have the same vector. So where this represents a scalar, just some number you multiply to change the length of the vector. And when you have the absolute value around here, that talks about the magnitude or the length of the vector. Okay, so let's look at an example. If you've got one vector here and it's parallel to another vector, then we know that, and we want to find the values R and S. I do not know why IB chooses to use the letter S as a variable, but they do. So you just have to be super careful, because I think S's can accidentally look like 5s. But it's in the book, so we gotta be prepared for that. Anyways, so since these are parallel, find the values. So the first thing we're going to say is, okay, so vector A is equal to a scalar times vector B. So I can write this out. Like this, where we say that vector A equals the scalar times vector B. And then I can look at each row. So 2 equals k times S, -1 equals k times 2, and R equals k times -3. Okay, now we can use this middle one to solve for k. So -1 equals 2k. If we divide both sides by 2, we get k equals -1/2. Okay, now I can use that value to solve for S and R. So here I can say, okay, I plug in -1/2 in for k. I get 2 equals -1/2 times S. Multiply both sides by -1/2, and we get this. Here we've got R equals -3k. We're going to plug -1/2 in for k, and then we get R equals 3/2. Okay. Now, unit vectors is when I change the length of this vector so that it's got a length of 1. Okay, so in order to make your vector, to change your vector so it has the length of 1, what we need to do is we need to multiply this vector times the reciprocal of the magnitude. Because if we do that, then what's going to happen if we multiply by the reciprocal of the magnitude, we're going to end up with a unit vector of 1. So let's do an example here. Okay, find the unit vector given this vector A. So I first need to figure out the magnitude of this. So to figure out the magnitude of it, what we need to do is we're going to use the distance formula. So 2 squared plus -2 squared plus 1 squared is going to give me the square root of 9. So the length of this magnitude is 3. Okay, so since that's the length, then I could say if I multiply by 1/3, then the length is going to end up being 1, because the length of this vector is 3 units long. So if I multiply it by 1/3, then it's going to be a length of 1 unit. Okay, so what if I asked an additional question, make the vector a length of 7 units? Well, all I have to do is take this answer and multiply it by 7. And that is your notes on unit vectors and parallelism.